What do we do now? So now we're going to put these into the calculator and actually find what each of them equals, because overall what we were being asked to do is find the direction and magnitude of the resultant force. So we need to have that resultant force overall before we can do that. Okay, so go into your calculators or open up your calculator. And here's mine. And we want to do 150 times cosine of our force, which was 20. And we're adding to that the second vector, which was 100 cosine of 70. So that's the x component. And then we're going to do the exact same thing for the y component. Okay, so we're going to do the exact same thing for the y component. You can tab up or arrow up and grab that, and all you have to do is retype these to signs. Or if you don't want to retype them, you can, of course, find them under the trig button here. And that's going to give us the y component. So 124.54 and 214.331, that's our vector. What does that mean? Well, exactly that. Our x was 124.54. Our y is 214.33, or 214 and 33 hundredths. So there's our vector overall. This is the resultant vector. Now for the last part of that. Last part is finding the direction and magnitude of the resultant force. So this is the resultant force, the resultant vector. Let's find the direction of this vector. To find the direction of this vector, remember that theta, let's do a different color. Remember that theta is equal to tangent inverse of y over x. So in this case, theta is going to equal tangent inverse of 214.33 over 124.54. So that's the y, that's this, over this. That's the x. So again, put that into your calculator. So tangent inverse, and here's what's nice. You can actually grab the exact values from up here. So you can do tangent inverse of the y value divided by the x value. You can be even more exact if you want to and go ahead and grab the actual equation that you started with. Just make sure you're using correct parentheses then. And there it is. What do I get? I get 1.04. So what's my angle? Oh, okay, so that's a good question. So I just got 1.04. Does that make sense for an angle? Not really. So I want to make sure that my settings are correct. I'm going to go into up here and then go into settings, which is number 7, and then document settings. And again, here it is. It's in radians. I want it in degrees. I'm going to make that the default so I don't have to keep changing it. And now we have the actual angle, 59.8 degrees. That's more reasonable. Wouldn't make sense for it to be 1 degree. So 59.8 degrees. Okay, so last thing we need to do is find the magnitude of the resultant force. So to find the magnitude of the resultant force, I'm going to do the square root of the x component squared plus the y component, also squared. And that's what I'm looking for. And again, go into the calculator. And you can actually type this in. So square root of the x component squared plus the y component squared. And that gives me the answer. Overall resultant force, the magnitude of the resultant force is 247.89. Does it make sense for you to leave it as a radical when you're already dealing with decimals? Well, no, especially because this is an application problem. It makes sense to actually find what this is in the decimal approximation for it, because you're already dealing with approximations as soon as you get into doing this kind of work, the multiplying by cosine of 20 or cosine of 70, and squaring 124.54, which was a decimal approximation, and taking the square root. All of that's already a decimal approximation, so your answer should be as well. So the very final thing that we found was the direction angle and the magnitude of the resultant force.